Hey everybody, we're going to start with section 8.2 now, which is how to do integration by parts. So this method, if you've never heard of this, is actually a really beneficial and useful method when you have certain types of integrals that you're working with and other techniques do not work. So we went through a lot of different techniques you can try in the last video in 8.1. But this method is really interesting, and I'll show you how this works. And it does take some getting used to, though, so just be aware of that. You do have to know the formula for it. So integration by parts. So you want to use this method, or it's used to simplify, pretty much with all of our integrals, simplify the integral. And it's specifically integrals of a certain type of form. So your book uses u and v, a lot of books do. So integrals of the form, in antiderivative of u of x, so just u is a function of x, times v prime of x dx. So basically the form is a product where part of what you're looking at in your integrand is a derivative of something else, which we know with integration anyway, we're working with derivatives and going backwards, but specifically the product is what you're kind of looking for. And I'll show you some examples. And then we'll actually work through some examples so you know when integration by parts is going to be the way to go. So just what I want you to see real quick is usually we just call this u. We don't really focus on saying u of x. And then the derivative of v with respect to x is v prime dx. This is just dv. Okay? And so when I give you the formula for this process, it's going to have a u and dv and then those variables in it. So some examples. When integration by parts is the method you want to use. So if you have, let's say, an integral of the form x cosine x dx. Okay? This integral here, this is not going to go so well for you if you try previously used techniques, like, for example, u substitution. The derivative of cosine is not present. The derivative of x is just 1. U substitution, you can try it all you want. It's not going to go too well. So integration by parts would be the way to go. There is a product here. So it matches this form where some part of this integrand is a derivative, the v prime. And I'll show you how to pick what's going to be u and what's going to be dv, because it's not always in the right order. Another example, the integral of just ln x dx. Okay. This actually fits this format if you consider one of your factors here to be just the number 1. There's like an invisible 1 here. Another integral that can be solved or found using this method of integration by parts is the integral of x squared times e to the x dx. Okay. Notice this product is of terms that are like you kind of think unrelated. X squared is not related to e to the x. The derivative of e to the x is not x squared and vice versa. So u substitution won't work there, but integration by parts will. One more example, and then we'll get into solving this. Integral of e to the x times cosine x dx. Same idea, where these factors, this is a product, and these factors are unrelated, but one could be represented as the derivative, and then we can work our way through this process. So, what is this formula? What is this integration by parts that I keep talking about? Well, here it is. The formula goes, if you are trying to find the integral, so you start with an integral that you're looking for, you're saying that integral is the integral of u dv. That's what you're starting with. That's what you're trying to solve. So that's the left side of your equal sign of your formula. What are you trying to find? Which integral? One of these semi-difficult integrals that previous techniques don't work with. What this equals. This is the part that's new, and this is the part that you're going to use to find these integrals. It equals u times v minus the integral of v du. Okay? And so here's my formula. I'm going to box it in to make it clear that it is important, and it is a formula. So you do want to have this available. You want to reference this as you're going through these problems, because you are going to start with this left side. You're going to have to identify some stuff, and I'll walk you through this in an example. You have to decide, well, what's u and what's dv? And I mentioned a little while ago, it's not always in the right order. So maybe this is u, but then this is dv, or maybe this is u, and then this is dv. I'll show you what I mean in an example. You start though with this integral, and the way you find this integral is by making it equal this, okay? And then the whole idea is that this original integral, so your original integral here that you are trying to find, becomes easier. So yes, there's a new integral in this work, but hopefully this is easier to find than the original integral. Okay, so right now this is hard to do, especially because we don't know this technique, but hopefully we can rewrite each of these, and I'll show you in the examples, in terms of an integral that we can figure out. So we'll go through and I'll show you exactly how this process works. Okay, let's jump right into example 1. We're going to find the antiderivative or integral of x times cosine x dx. Now, when you were learning derivatives, you learned the product rule. The product rule worked for derivatives, but if you go backwards, if you're finding antiderivatives, there's not a product rule. And so you kind of are addressing that with this integration by parts technique. And your book actually has a nice derivation. It derives this formula for you. So if you're interested, like, where the heck did this formula come from? Go look at your book, section 8.2, and it shows you some steps for where this came from. So what you have to do in order to use this process, you have to identify what's u, what's dv, because that's the integral you're starting with. And so this is how I usually do it, and you'll see a lot of people do this setup. I need to know what u is, and I also need to know what dv is, because those two make up my integral that I begin with. And then notice what you need as part of what this equals. You need to know what v is. You already pick u, you need v, but you also need du. So what you need as well is du and v. So you need these 4 things in order to use this process. And so what you do, you pick 2 of them, you find the other 2. So we have, I'm going to say it like this, especially for this first example. In the future I won't write all these words on our example, but I do want to make it clear. You have to identify u, and you have to identify dv. Meaning you look at it and you pick it. And then you find the other 2. So then you're going to find du and you're going to find v. And so think about how you find those 2 things. Well, if you know u, you just take the derivative to find du. Okay, so I'm going to put differentiate. I'll just put it as diff. Differentiate. You pick u, differentiate to find du. Well, maybe you can tell me this one. If I know dv, how do I find v? This is the derivative, so you integrate. Okay, so you integrate dv to find v. Alright, that's the idea. In order to use our formula, we need u, v, and du. We start with u and dv. So this is like my table, my setup. So this is all pretty much side work right here in order to work with this integral and use integration by parts. Okay, so let's make some decisions, and I'm actually going to do it 2 different ways because I want to show you like the realistic approach, because you might not know, especially if you're starting this process out for the very first time. Well, what do I pick for u? What do I pick for dv? And so I'm going to show you both ways, and then I'll show you why one is going to work and one's going to make it harder. So option 1 and option 2. Let's break this down. Option 1, we're going to make our table, and then option 2. And you do not do both. I'm just showing you both, just so when you do this on your own, you'll know, like, okay, sometimes my choice doesn't work. So maybe I should try something else. Okay, so in all cases though, you need to pick u and dv. Okay, so option 1, let's go ahead and just stick with the way it's already written. So u is first, dv second. It doesn't really matter which way it's written, but I'm going to say that this is u. So this is u, and so that everything back here is dv. So this is the integral of u times dv, or u dv. Okay, so this is my choice I'm making. U is x, dv is cosine x dx. And then what I would do is I would find the other two pieces. I would find du by differentiating, and I would find v by integrating. Before I find those, let me show you what the other option would have looked like. Okay, so option 2. Let's say I look at my integrand again. So u here, dv here. Let's just say maybe it was already written the opposite way. I'm going to rewrite it just so you see what I'm talking about. But maybe it was written like this. Or maybe I wanted to write it like this. Cosine x times x dx. Okay? So maybe it was written like that, or I wanted to write it like that. And so maybe I would say that this cosine x is u, and the x dx is the dv. Okay? So u is cosine x, dv is x dx, and then I find what I need, the rest of what I need. I find du by differentiating, and I find v by integrating. Alright, so what I want you to try real quick, pause this, and then figure out du, figure out v for both option 1 and 2. And then I'll show you what it is in just a minute. Is this what you found? So you integrate, or you differentiated x, you got 1, but put the dx on there as well. And then you integrated cosine x, integral of cosine x is sine x. Option 2, derivative of cosine x is negative sine x dx, and then when you integrate x, you get x squared over 2. Okay, so let's see what would happen with both choices and then decide like which one was the better choice. Now, I'm not going to do the entire formula at this step because I don't know which one to choose just yet. I'm still deciding which option, 1 or 2. So I'm only going to focus right here on this integral, and then when I'm ready to go forward, I'll consider the whole formula. Because remember what I said when we started, the whole point of this formula is to make this integral easier by using this integral. So if this integral is not easier, then we just don't use that option. Okay? So I'm going to focus on just the integral. So this is what I'm focusing on. Integral of v du. So option 1, v is sine x. Du is 1 dx. Okay. Option 2, integral v is x squared over 2 du, negative sine x dx. Alright, now you tell me which one's easier. I hope you see it. This one, way easier. So this is easier. This is easier to evaluate than this integral was, the original, and this integral over here, this is actually harder. This is harder to evaluate than the original. We have x to a higher power. We still have a trig function like we did originally. So option 2 was not the best choice. So I did want to show you both options because when you're trying this out, especially when you're trying it on your own and for the first few times, you don't know which option's the best, but you do try it, and then you'll start to see which option becomes better. A lot of it has to do with decreasing like a power of your variable. So for example, let me just tell you what I'm talking about with this one. With this option, because I'm differentiating u, what I picked for u was x, it decreased that power. It was x to the 1, now this is like x to the 0. Over here, when I picked this option for dv, it increased that power of x. My choice of u didn't really help much, it just changed from one trig function to the other. So you'll start to see like which choice is better when you do these problems. So now we know option 1. I'm going to go ahead and clean this up a little bit and then we'll finish this example. So let's finish this example 1. We already decided that this was the best choice for u and dv, and we found du and v accordingly. So this integral is this left side of our equal sign for our formula for integration by parts. So this is the integral of u dv. So the right side, what this equals, is u times v minus the integral of v du. Okay, so u times v, let me just stay color coordinated to make it really clear to you guys. So u times v minus the integral of v du. Now, we already talked about it, way easier integral than the original and our other option. And so let's evaluate this real quick. You can make this look a tiny bit nicer. Just get rid of that 1. So this is integral of sine x dx. And the integral of sine x is negative cosine x. Technically it's going to have a plus c because there's no limits of integration. So my final answer, don't forget the uv, that's part of the answer. So this is x sine x minus a minus, okay, because this is the antiderivative of sine x. So minus a minus, so plus cosine x plus c, there it is. So that is the antiderivative of x cosine x dx. All right.